everyone. My name is Mackenzie Mitchell.
My name is Ian Canterman.
And my name is Jake Morris.
And today we'd like to present our senior capstone project. The title is Wrist Pulse Simulation Technology Capable of Representing 28 Pulse Patterns of Traditional Chinese Medicine. Now, I'm sure not all of you are familiar with traditional Chinese medicine, but it involves several ancient practices that have been developed over the past 2,500 years. And so, So it is derived from several concepts of Chinese philosophy, namely qi, which is the vital energy or breath, life energy, and then also yin and yang. So yin and yang are essentially two opposing energies that are interconnected in some way, shape, or form. Relating to pulse diagnosis, yin is disease and yang is health, and so the qi alternates between yin and yang, and your body tries to achieve some sort of balance. And so pulse diagnosis is achieved by you place 3 fingers on your radial artery and you feel the pulse. And this is said to, it reveals something about the health of the person. This is what the Chinese believe in their medicine practices. And so there are several limitations in trying to teach this because there's 28 pulse patterns, and a lot of them are described in a strange way. You have to describe how something feels. And so they use things like, it feels like rolling pearls, and a lot of people can't really picture that without actually it being demonstrated to them. And so what we're trying to do is create a teaching tool for teaching this ancient practice to kind of standardize the practice and improve the reliability in the future.
So in terms of the goals, we are building upon the last group. We are currently the 3rd rendition working on this PulseSim project. And so the last group, just to kind of recap on what they've done already, they've created a silicone hand model with a wrist, a compartment inside it with electrical solenoids that are driven by current and are used to actuate the feeling of a pulse. And then furthermore, in addition to that, they created an Android app which can be implemented on an Android software called PulseSim, shorthand for Pulse Simulator. And so now what we are trying to do is improve that by representing most of the 28 pulses in traditional Chinese medicine. Now, in order to do that, we have questions that we have to ask ourselves, and that is, how do we categorize the 8 different characteristics in a pulse? There is research done, and there are articles that describe these 8 characteristics, and you can kind of see it here in this little box. So each characteristic has a section that is affecting a typical systolic and diastolic pulse in your radial artery. And so what we have to categorize is what is quantitative and what is qualitative. So in terms of quantitative, these characteristics can range from depth, rate, to strength, your width, and also length. So these characteristics can be quantified via mechanical, electrical, or computer means. Whereas qualitative characteristics are more abstract, and as we said earlier, it's more so how do they feel. Those can range from smoothness to stiffness and regularity. And now what we're trying to do is represent those. And so that raises a lot of design questions, which Jake will now go into.
So this year's project focuses a lot more on software, but obviously we will be improving the hardware that was previously designed. So currently the hardware, as Ian explained, uses a microprocessor to drive current into 3 solenoids which push up against your fingers and represent or simulate the feeling of a pulse. Now, what we want to do is to have a finely tuned, polished product, and so what we're planning on doing to improve hardware is to recreate or improve the existing hand model by making it more realistic. We're going to make another mold with a different type of plaster, and it's going to be the color of your skin. We are going to redesign the box that contains the 3 solenoids to make it smaller, more compact. And lastly, we are claiming novelty on designing variable-sized solenoid caps, which will represent the arterial width, which is a characteristic of one of the characteristics of the pulses. Now, on the software side, we are looking to manipulate the this curve right here that you can see. We need to manipulate that in order to achieve the desired characteristics of these 28 pulses. Now, for some of these characteristics, it's pretty obvious how you can achieve this. For example, for rate or depth, we can use frequency modulation or amplitude modulation of the systolic phase. But for others, such as smoothness or stiffness, it's not as cut and dry due to the qualitative nature as Ian described. So, for example, we have here sort of a prototype of what a smooth pulse may look like, and essentially it's a pulse that has no rough edges, and the dichrotic notch has been dropped down to create sort of that smooth flowing feel of pearls beneath the fingers. Now the stiff pulse is going to have a very sharp peak on the systolic phase and almost virtually no dichrotic notch, so it's like you're holding there's a hard rope beneath your fingers. Now, if we are able to successfully characterize these 8, or successfully implement these 8 characteristics, we are hoping to be able to achieve all 28 pulse patterns of traditional Chinese medicine. And with the successful implementation of this project, we hope to create a new platform for the traditional Chinese medicine pulse diagnosis. Thank you.
Any question? Give us an example. What was the most difficult pattern to implement?
We have so far worked on modeling the 8 different characteristics, and then we're going to use those and just kind of combine them to make the more difficult ones. Like there's some, like for example, this one is purely qualitative. Okay.
Sorry.
So that one's called slippery, and all they give for a description is rolling pearls. It feels like it's rolling pearls. But for other ones, they kind of combine, like you can feel it at a certain pressure, and then the regularity is different than a regular pulse. And so you kind of combine, like, I think the most difficult one has 5 different characteristics represented in it. So once we can, and actually we're well on our way of representing all 8 characteristics, we'll be able to do the 28 different pulses.
And for example, I think there's one pulse that is strictly characterized as the feeling of a guitar string, which, I mean, it's not something that you can easily picture or put into a scientific, like some kind of engineering model. You know, it's strictly based on the feel beneath your fingers.
Thank you very much.